Yeah.
Okay. This past year, 600,000 people in the United States died of cancer. This means that every day, 1,600 people lost their lives and 4,600 new cases were diagnosed. In addition, of the 4 million babies born into the world each year, about 3 to 4% of them are born with some genetic disorder, many of them seriously life-shortening. Medical ailments such as these affect a large portion of the population. An even greater portion of the population is affected indirectly, suffering along with friends and family members. Now, fatal diseases such as these are serious limitations to world health. However, they may not be for long. Human biology, at its most fundamental, operates at the nanoscale, and nanotechnology offers the opportunity to intervene within the body at the cellular level, attacking cancer cells directly and even replacing faulty genes. Now, what exactly is nanotechnology in the nanoscale, and why does it hold the key to solving today's most pressing medical issues? Well, nanotechnology involves the creation of technology at the molecular level. That's length scales between 1 and 100 nanometers in length. Now, exactly how small is that? A single sheet of newspaper is 100,000 nanometers thick. And if a marble were 1 nanometer in length, a meter would be the size of the Earth. Now, one reason why the nanoscale is so special is that at these minuscule lengths, physical properties change. For example, a block of gold is gold in color. But at the nanoscale, a particle of gold reflects light differently and appears red. Similarly, properties like electrical conduction and melting point change at the nanoscale. Scientists can use this knowledge of nanoscale properties to their advantage, crafting devices and materials that allow detection and treatment of disease. Now, for the research portion of my senior seminar experience, I look into nanotechnology in the field of medicine, or nanomedicine, and the problems it can address. 3 areas of medical treatment stood out to me: cancer detection and treatment, gene therapy techniques, and the treatment of neurological disease. Now, nanotechnology has great potential for cancer detection and treatment. An example of cancer detection technology involves the use of gold nanoparticles, which, as previously mentioned, are red. When these particles come across cancer cells, they tack onto them, and as time goes by, a number of these particles accumulate at the site of cancer, and collectively, these particles appear blue. Thus, cancer cells are detectable because of color change at the nanoscale. An example of cancer treatment involves the use of a device called the Nanobeam, which is shown above at the right. This device consists of a nano-sized spherical shell that contains bee venom, and this is known to kill cancer cells. It's also equipped with a tracking molecule that hunts down cancer cells. And when this device packs onto the cancer cells, it pops like a balloon, releasing the venom and killing the cancer. In this way, the cancer cells are eliminated very specifically. And instead of having harmful side effects like chemotherapy, which affects both cancer cells and regular cells, there are no side effects. Now, gene therapy techniques are the holy grail of genomic research. Genetic disorders like cystic fibrosis and Huntington's disease have been virtually untouchable for much of human history. And just recently have we been able to treat the symptoms. But now we may be able to fight the disease at its underlying cause. An example of gene therapy technology involves the use of viruses. And these viruses are very special because their DNA has been altered. And their DNA is the same as that of healthy cells. So what these viruses do is they go into the disease cells, they alter the DNA, and they replace it with their own. This means that they eliminate the genetic disease at its source. These viruses only work because they're small enough to enter individual cells and interfere with individual DNA molecules. And they can only replace faulty DNA because they've been altered at the molecular level. Now, neurological diseases like Alzheimer's and ALS affect the brain severely. And because the brain is the control center for all other body functions, neurological diseases will eventually lead to death. Now, there's an example of technology to tackle neurological diseases. Neurological diseases like Alzheimer's and Parkinson's are caused by these molecules called free radicals. And these molecules destroy cellular structure and eventually eliminate much of the brain tissue. Now, these nanoparticles of cerium oxide have been found to neutralize these free radicals. And when administered to a patient continuously, they can curb the effects of neurological disease. Now, these technological advances are very exciting, but there are several things required to turn these discoveries into a full-fledged nanomedical revolution. First, people need to learn about these discoveries and lend their support to continued research, because nanotechnology is understandably very expensive. Also, problem solvers are needed to conduct research on nanotechnology, to work out problems with existing solutions, and find new solutions to existing problems. Now, over these last 5 months, I've worked through a college course on nanotechnology and the properties of materials at the nanoscale through the MIT OpenCourseWare website. This study has enlightened me about fundamental aspects of nanotechnology, and all of the content of this course and many others is available online for free for anybody to pursue. The ability to acquire this vast array of knowledge is very easy. It's as easy as turning on your phone and searching for this website. The other barrier to nanomedical progress is of concern for safety. Nanotechnology has great potential to solve problems, but it also has potential to cause other problems. For example, cancer therapy could target the wrong cells, or gene therapy could replace the wrong sequence of DNA. Because of this, nanotechnology requires years of research and medical trials to ensure that it works correctly. Now imagine that you or a loved one are diagnosed with cancer. Current medical treatments are lengthy and have serious side effects. Procedures are invasive and potentially dangerous. But what if there was another option? Nanomedical therapy that targets only diseased cells, quickly and efficiently eliminating the cancer, leaving you to continue living life as you normally would. All right, I'd like to thank my mentor, Dr. Newman, for offering a hand of guidance through the course, through my progress in the course. I'd like to thank my senior seminar teacher, Mrs. Dustin, for answering all of my questions and helping me to solve problems and structure my senior project. And I'd like to thank all of you, teachers and students, for coming to watch my presentation. Thank you. Now, does anyone have any questions? Okay, thank you.
Thank you.